All right, so we're picking up on this video series on perfecting our cuts, and we're about to cut real time for real business 100 of these, a little production run of these, and this is a sample that was cut. As you can see, it's got a pretty nice cut overall. You know, most people would be pretty well happy with that, but maybe we can get a little better. So the first thing you want to do is kind of diagnose what's going on. And if you look at this, I don't know if it's showing up on camera, but the outer edge of it, I'm going to put it down where we can see it a little bit better here. The outer edge of it, if you just grab it with your fingernail, you can feel a little bit of a burr. You can't see it too much. There you go, you can see it. But the holes and this big radius right here has a pretty noticeable burr. So we want to make a few adjustments, see if we can get that dialed in. But because this is an acceptable part, just like it is, we're going to nest this thing and let it cut. And while it's in production cutting, we'll make a few tweaks and see if we can improve it, and we'll take a look as we go. All right, so the first thing we're going to do on this that we know that we want to do is we're going to turn on dynamic power adjust. And that basically what that does is it slows down, or it actually turns down the power of the laser in relation to the speed of the machine. And everybody knows when you're cutting a hole or you're cutting a radius, the machine goes slower than it does running in a straight line. So we're going to do dynamic power adjust and set that up now. So in SIP cut, we're going to go to the layer screen, there or there. So bring up our standard layer. Here's what we normally are going to use. And what you want to do is click the power curve. So we turn on dynamic power adjust right there. So now we have dynamic power adjust. We want to edit the curve there, and let's take a look at these numbers. So with the way this is set up, we have obviously at 100% speed, we have 100% power. At 58% speed, we have 87% power. And at 28% speed, we have 65% power. I think that's a good starting point. We can come back and tweak this, but basically you want to make sure that, I mean, basically what this is doing is, you can see when the machine is running at 50% slower than its target, it's running at 87% power. So I think we do want to tweak that a little bit. Let's grab that 87%, which is going to be this dot right here, and drag that down just a little bit. There we go. Get it down, there you go. Now we got it down to about 79%, a little bit more of a linear curve. So that's the first thing we're going to do. Here we go. Yep. All right, you see that this thing has got this particular set of settings has a pierce set up with it. So we want to eliminate that. And so we're going to come over here and open the parameter screen. This is kind of a basic one. So if you're new to this, some machines at certain power levels will need a dedicated pierce, others do not. So we want to go ahead and make this a no pierce setup. All right, so if you're mid-cut in a job and you've paused it, you're not going to be able to turn off the pierce. So what we had to do is stop the job, and it's a little learning lesson for you here, even though we're dialing in a cut, just kind of showing you a little something. So no pierce, and then we're going to say okay. And then what we do, since we've already cut the first two, we're just going to deactivate these two. So you want to highlight them, and then come over here and press the X right there to deactivate those two. And then now we want to return the machine to home. So Bob, if you do function 0 on the remote, hold function down with one finger and then hit 0. Now it puts it back at the 0 position. It's going to skip those two because we deactivated them and pick back up where we left off with no pierce this time. So let me get my glasses on. Pause it after it's done. Okay, back it away so we can look at that part. So let's go ahead and grab one of the parts out now. And let's take a look at the changes that we made with the dynamic power adjust. Should be cool to the touch with nitrogen. And we micro jointed this part in there so we can get that out. All right, so let's take a look here. And we still have a little bit of a burr. We didn't completely eliminate it, but I believe it is a little bit better. You know, you see on this one around the edges, the radiuses, looks a little bit cleaner to me. So I think it's definitely good having that in there. All right, so we're picking back up. We still have a little bit of a burr on this that we'd like to possibly eliminate. So the next thing that we're gonna try here is the focus change. So the set of parameters that this machine set up with right now has a 90 thousandths focus, basically, you know, 89 thousandths. So I think we want to shallow that up. And if you refer back to the beginning of the video where I talked about the target focus and where you want to be and the way this system works, we're going to use some of that methodology and give this a 0.05 focus as a negative 0.05 focus. That should put us somewhere around the middle way through the material as the focal point. So we're going to say okay now, and we can resume the cut from where we are because we just paused the machine and see if this has a positive effect. All right, so we're looking at one here that with that focus change that we just made, and if you look at the edge, we definitely have improved it. It's not completely eliminated, but it's certainly better. So we're going to try to go a little bit more shallow with the focus and see what that does to it. So let's go layer, and to just make a little bit of a radical jump, we're going to go to 10 thousandths, a negative 10 thousandths. That's going to put it above the top of the sheet. So we're going to say okay, then we're going to resume the cut, and then we'll check it again. Don't know if you were noticing in the cut, but notice very consistently on the ones we were cutting before, the holes always dropped out, and all of a sudden here, we don't have the holes dropping out. Okay, and then we're also having a little bit of a difficult time getting this to come out where these were just loose in there. So that's telling me that we have made it worse. So we basically found our perfect focal position previously. You see that? It's not even really coming out. And let's see if we can dig one out of there and look at the back of it. It's going to have a noticeable burr on it when we get it out. Okay, so you see the summary here. We started off with a negative 0.089, and we changed that to a negative 0.05, and we got some improvement. So then we went even shallower with it and went from negative 0.05 to negative 0.01. And you saw the degraded performance. And this is the method that you want to use. You want to, you know, search high, search low, go beyond the range, see that it's degraded, and then come back, you know. And again, just showing the summary here for the folks looking at this in metric, we went from a negative 2.2 millimeter to a negative 1.27 millimeter. We got improvement, so we went further in that direction from negative 1.27 millimeter to 0.25 millimeter negative, and we got degraded performance. So it's going to be back near that range that we started with in that negative 1.2 millimeter range or the negative 0.05 inches range. Okay, so you see there the ideal focus range in this case is going to be negative 0.04 to negative 0.06 inches, or negative 1.18 millimeter to negative 1.35 millimeter. So you may be asking, why didn't you show further refinement of the focus? And what you'll learn is that once you kind of get in that ideal range, let's say you've got it at negative 0.04, if you change it to 05 or 06, it's not going to change. Same thing metric, if you're at 1.18 negative millimeters and you change it to 1.35 negative millimeters, you're not going to see a change. It's that drastic, you know, high and low that you're looking for. And in general, you might be asking, well, you know, why did you go low and not high? Well, if you refer back to the demo that I showed you, or the explanation about that your focus range is always going to be somewhere in the middle of the material, near the bottom of the material. It's almost never going to be way through the bottom of the material unless your autofocus servo is way off in its calibration. And it very well could be. This machine was not. So we're still noticing in the radiuses and the circles that we're getting a little bit of burr that's a little bit more than normal. So I've changed the dynamic power adjust even more to turn the power down even more at a slower speed, and we'll see what result we get. So we're going to cut another one now. Okay, we found our focus position that we wanted, you know, looking for the range in the previous segment. And then we also made a further refinement to the dynamic power adjust, as we just talked about, and now we're cutting another one. All right, we'll take a look at that one. Woo! A little warm, even though we're cutting with nitrogen. Yeah, we're still, I think that's the pierce right there on this corner, but every one of these has a noticeable burr. So I think we might have to work on the pierce routine a little bit, and the lead line to get that a little nicer. All right, so we just made a couple of changes. You can see, like right there and right there is the lead, the start point of the lead. So we have added a larger radius and put the lead closer to the center. And then we've also, we went ahead and added a slow lead. So right here, slow lead, and the first little bit of the lead, 30 thou, we're gonna run at 200 inches a minute, just to let it work into there, see if we can eliminate that. So we're gonna try that now. And we've also added a larger nozzle. We're running 250 PSI of nitrogen. We've got 14 gauge cold rolled, and we now have a 2.5 millimeter nozzle in there. So we're gonna pick back up and go from there. All right, so there's the outer edge, and you can see it's pretty well burr free, but we're still getting some funkiness around the holes. So what we've done here is, if you go into the layer screen, I've basically I put the holes on their own layer, so they're on the yellow layer, and we got the holes cutting at 500 inches a minute. And we got the rest of the part cutting at 350 inches a minute with the long straightaways. So we're gonna see if speeding up the machine will clean up those holes. All right, so we've made our final adjustments. We've got a pretty big nest of, 100 parts. And we're gonna cut the first one and check the speed on the holes and see if we've made some improvement. So fire away. All right, this is gonna finish up this part of the nozzle, or the module here on this part of the video. So you saw in there that the machine's running full production, and we're pretty happy with the results that we're getting. I wanted to try to show you this at some angles where you can see it. I'm trying to get the light where you can see this. So this is where they started, you know, when I got here. This is the settings they were using. And it's not bad, actually. I mean, a lot of people, you know, they were actually happy with that and they were going to go with it. I'm just trying to hold this at certain angles where you can see the little, you know, the little burr on the edge. And you may not be able to see it in all, you know, in all areas, but if you rub your fingernail across it, you definitely can catch it. This one is about halfway through our process. We were making some improvements. It was definitely getting better. You can still just kind of faintly feel some stuff, and you can see the holes, you know, you can see a pretty noticeable burr there. And then look at that same hole on this one. And it's got a little nib right there, but overall it is slick. I mean, you can't grab it with your fingernail. The edges are perfect on it. So with a little bit of time and finding the right focus, finding the right speed, and you know, the gas adjustments, looking for the nozzle, we ended up with back on a 1.5 nozzle with this. The 2.5 does clean it up a little bit, but man, you're using so much more nitrogen with that. So all right, guys, that'll be it for this section. And again, anything you're cutting with nitrogen, so stainless, you know, in this the same thickness, 14 gauge or around 2 millimeter, the same principles apply. So if you're cutting stainless, carbon steel, aluminum, you can generally use these same methods for the troubleshooting. All right, guys, so here's the summary of the changes that we made. First of all, we enabled dynamic power adjust. And then second, we worked on the focus a little bit and found the perfect range and got that optimized. We tried stepping up to a larger nozzle. And usually you will find with nitrogen or compressed air cutting, going with a larger nozzle will almost always improve your cut. But then you have to make a decision, you know, is the extra, you know, nitrogen or assist gas that you're using worth the improvement? In this case, we ended up moving it back, but we've made further refinement to the dynamic power adjust. We added a lead line and slow lead, and then we lastly optimized the speed for the holes versus the outside cut.